Hello, welcome back to the training purposes. Let us start with algebra today. So we are going to master algebra for placement successes. Under this we have different categories, but I hope you have already gone through the module 1 to be understanding the numbers well, so that it is easier for you to understand the algebra part of it. So now when we talk about algebra, it's more like you have a lot of equations to solve. You have an understanding of numbers, and that's how you come to this part of the module. So if you haven't gone through the module, please make sure that you go through the first module and then come back to this algebra module, where we will be discussing about linear equations, quadratic equations and progressions. So it is quintessential for you to understand the module 1. So I hope you have done that, and for those who have already done it, good job on that. Now let us start with mastering algebra for the training purposes. Great, I hope you have again gone through module 1. Anyways, coming back to this module, so here we will be doing most of algebra. So here our agenda is understanding linear equations. So linear equations are mostly, like I said in our previous module also, we have x power 1 as the highest degree of any given polynomial. So we will be understanding this in depth. We will also be looking across quadratic equations when x power becomes 2. There is something more called as cubic equations, where x power 3 is considered, but as of now for training purposes that is not required for us. Hence we will only be concentrating on the linear as well as the quadratic equations. Post that, this is a very important concept called as the progressions. Here we have in general in mathematics, we have three types of progressions. One is arithmetic progression, geometric progression, the other one is the harmonic progressions. But as of now, for this training circuit, we only have to understand the arithmetic as well as the geometric progressions as to how they work, what is the sum of all of it, what is certain term of it. These are the basic things that is generally asked in any aptitude sort of question. So make sure you pay a lot more attention to this particular topic, which is progressions. Then we have a little bit of practice questions. We've made sure that the kind of questions that is put together is from the past papers, so that you have a better understanding as to how questions are being asked. And then we will be doing the summary of this entire thing. So this module is going to be a little shorter than the previous one, but then this is going to be a little more exotic because we already have a bit of understanding of the number system and all of that. So make sure you again and again practice the module 1, which is the number system, and then come back to algebra. Okay, let us start with the linear equations, which is our first topic for this entire module. Linear equations, linear in general means straight, or something going in one complete line. So linear equations, as the name says, linear, for a given equation, the highest degree is supposed to be 1. So 1 is our highest degree. Now coming to the definition of it, now you don't essentially have to remember the entire definition. All you have to know is this is of the form ax plus b equal to c, or since this equation is given to us, hence we call it as equation. This can also be 0 or anything of that sort. C is just a constant given to us, where ax plus b equal to c is our generalized equation. So for this a, b and c that you have, they are all constant values. This x is known as the variable. So x gives us the variable value, whereas this a, whatever is with your variable becomes your coefficient, and everything else, b and c, are majorly constants. So b and c are constants. Now to understand this better, let me take a different color so that it becomes a little understandable for you. So first thing is this variable. What is exactly a variable? Now, for example, let's say you've been growing up ever since you were born, right? So whatever your height was at the age of 4 is not the same as at the age of 20 or whatever your age might be. So what is happening? Height is a varying factor. But your parents, they are constant, right? Your parents did not change, of course. So therefore, we can say wherever you see something is varying, that becomes a variable. Whatever is always with you becomes a constant. Now this coefficient is just a generalized value which is multiplied to a variable. For example, let's say we started, like I said, your height, it started with, let's say, 3 feet, and then you multiplied something to it and it gave you a different value which is 3.5. So what did I multiply? 0.5. So that 0.5 is going to tell us what the coefficient of a given variable is. So that is how linear equations are generally understood, with variables, coefficients and constants. Now there are different properties for linear equations. Majorly these two properties. Let's take back our red color. So here has one or infinitely many solutions. What does that mean? Now let's say I have ax plus b equals 0, right? From here, when I send this to the other side of the equation, it becomes negative. So ax equals minus b. Now when this is in multiplication, so when I send it to the other side, it becomes division. So x is equal to minus b by a. So this is a definite value. This is what they are trying to say has one solution. When it has to come infinitely many solutions, I can say there are two variables, x is equal to y. Now whenever I keep on giving values for x, the y value keeps changing, right? Or we can just simply say y is equal to x. I give value to x, let's say x is equal to 1. So y will also be equal to 1. X is equal to 2, y will also equal to 2. So what is happening here? Because there is a change in one variable, there is change in other variables also. But here we are talking about variables, we are talking about two variables in a linear equation. Whereas here we are only talking about one variable with different coefficients and constants. So whenever you have more than one variable, it is possible to get infinitely many solutions. There are so many solutions here, right? 1, 2, 3, 4. It can go on, it is never ending. Therefore, we say it is infinitely many solutions. Whereas for a single given equation, there is just one variable, you only have one solution, therefore has one solution here. Coming to the second part, this represents relationships between two variables. Now, just like I showed you here, what did I try to say? I was saying there is one variable which is equal to the other variable. Now, what does that mean? Let's say you have a twin brother, right? So, brother or sister, whatever, just make your imagination go wild now. Let's say you have a twin brother, you are growing, with you your brother or sister is also growing. So the variables there are the height factors, but general variable is what? You and your twin brothers. Those are not constants. Of course, you are growing day by day or year by year for that matter. Hence, we would say it represents a relationship. What was the relationship I just spoke about? It was simply height. So everything put together, we can say a linear equation has one or infinitely many solutions, provided for infinitely many solutions I have two variables, for one I only have one variable. Represents relationship between two variables. Now I gave you an example of height. You can think of plenty of examples that way. Now let us come to examples. So we have here 3x plus 4 equals 1. Now this is a linear equation because I know the highest value of x is 1. Next is x minus 5 equals 10. Again, x has the highest value as 1. One more thing that you need to have a note of is, since this is linear equation and x's highest degree is 1, right? Highest degree is 1. So the number of solutions for one variable at a time is simply 1. For first degree, for any degree 1, number of solutions for one variable at a time is 1. Of course, I have told you infinitely many solutions, but also remember I have specified here saying we are only talking about one variable. So this particular equation here, so it has only one variable and the degree is 1. So therefore this equation will only have one solution. Now in your interview aptitudes, generally what they do is they do not really tell you or generally ask you anything from the infinitely many solutions part. So generally what they do is they give you two variables and they just ask how many solutions is possible to have here. So remember, when there are two or more variables in a linear equation, it is always infinitely many solutions. But for only one, it is just one solution. And mostly questions are based on just one solutions, asking you to find the value of this, and the equations are also generally very simple given to you. So make sure you understand linear equations. General equation is ax plus b equals c, where a is the coefficient, x is the variable, b and c are constants. It has two properties, has one or infinitely many solutions, represents the relationship between two variables. Since we understood what linear equations are, now let us practice a few problems to understand exactly how it works. So the very first problem is, so first look at the problem, identify if it's a linear equation or not, because we also are talking about quadratic equations. So first identify, is this a linear equation? Yes, of course, because the highest value of x is 1. Again, remember, polynomials cannot have fractional values. If so, this is a fractional value. So this is technically meaning root x. Remember, we were talking about surds and indices. So there I told you 1 by 2 is simply this. So this is a rational number. Hence, always remember, for polynomials, the degree value starts with 0. 0, 1, 2 and so on. Why am I considering 0? Because x power 0, remember, for a non-zero, if this is not 0 and I have a power 0, this becomes 1. So hence polynomials will have the power starting from 0, but for linear equation the power is supposed to be 1. Let us come to solve this problem. Now 5x plus 3 equals 18. Now with more practice, you would be directly able to tell me what the solution of this ideally is, right? But then, since we don't have practice, since we are all laymen right now, we will first find out using equations. Now sending this to the other side, this will be 5x equals 18 minus 3, because here it is positive, it goes to the other side and becomes negative. So 5x is equal to 18 minus 3 is 15. Now since here it is in multiplication, I will send it to the denominator. So this becomes 15 by 5. Now x is simply equal to 3. Right? 5 ones are 5, and again we are using divisibility rule here. So in the end, since it's 5, it is completely divisible by 5. So our final solution is simply 3. Now if you had good practice of this, you would have directly been able to tell me. In your mind, 18 minus 3 is 15. 15 by 5 is simply 3. So it would hardly take you 2-3 seconds with more practices. But if you don't have practice, then you will have to go through all these steps alone. So make sure you have your pen and paper ready and always practice. Okay. So let's come back to our second problem. It says 2x minus 4 equals 8. So we have 2x minus 4 equals 8. For those who can directly do the solutions, amazing job. But for those who are not yet able to solve mentally, make sure you're practicing, so that way again you will be able to do it better. Now let us just try and solve it mentally. I know for x, everything has to go to the right hand side. So this will become plus here. So 8 plus 4 is 12. 12 by 2 is 6. So our direct answer is 6, just doing it mentally. But then let's check if it's right or not. So this becomes 8 plus 4. I know 8 plus 4 is 12, so 2x. Now x is equal to 12 by 2. Again, for divisibility, what did I tell you? For 2's divisibility, it is the unit place is either supposed to be 0, 2, 4, 6 or 8. So out of these, I have 2 here. So clearly x is equal to 6. So we were able to solve it without even doing all of this, just mentally with a bit of practice. So that was about linear equations. Now let us understand a bit about quadratic equations. Now here generally you will have a degree 2. So now remember I told you there you will have one solution, right? So what do you think, how many solutions can you have here? Since x degree would be 2. Now let us not look at this, don't look at this as of now, just with this quadratic means 2. So x should ideally have 2 solutions. Right? So this is ideally supposed to have 2 solutions. But when we are solving these, I will tell you as to how these 2 solutions change. Right? So let us first understand the definition of it. First is an equation of the form ax square. Now I told you this power, this means power, right? So ax square plus bx plus c equals 0. So this is our general term or generalized equation for quadratic equations. Under this, what is the key feature? So we have the solutions are called roots, right? So there are different nature of roots as well. Right? So we are talking about solutions are called as roots. Roots, what they have nature of roots, saying if they are real, if they are complex, if they are repetitive, or if they are different from each other. So all of this come under nature of root. For that I will be using this particular equation. We will be doing that and be understanding. So this can be solved using mainly 3 components. One is factoring, or this is simply factorization. And next one is completing the square. We will take one problem and we will find out using all 3 methods if we are getting the same solution. You can pick one of it and then solve it. Generally, we don't go for completing the square method because we are not solving parabolas for that matter, right? But quadratic formula as well as this factorization that we have is the very generalized usage of that. But then you will also find difficulty doing factorization for larger number. Hence, we mostly go for quadratic formulae, which is I'll tell you. We generally go for quadratic formulae so that it becomes easier for us to solve any problem. Now factoring is factorization. I told you completing the square. I will teach you how the method works. Then there is quadratic formula. Quadratic formula is simply x equals minus b plus or minus under root of b square minus 4ac whole divided by 2a. Now here it was difficult for us to put all of that together, right? So make sure you take a note of this one, hence it is easy for you, right? And then there are examples. So now here, one more thing that you see is, here for this quadratic equations, we have an extra x here. Now why is that? That is because we keep decreasing our values, right? Now for our linear equation, we had ax plus b equals c. Now if you noticed, this was 1. I told you x bar 0 is 1. So 1 into b. So ax1 plus bx bar 0 equals c. So this is how actually it looks like, because this becomes 1. B 1 into anything is that particular number, therefore we generally don't write this. But here you can see it very clearly. We have a x square, then there is x, then c into x bar 0. So x bar 0 is 1, so that's why we don't write that x bar 0 there, but x bar 0 is always there, just remember that one. Now coming to solutions called roots, so let us find the roots of this particular equation. It says x square minus 5x plus 6 equals 0. Let us first start with factoring. How do we factor? So this is a multiple. We know we have, if we have multiple, if 6 is a multiple, 2, 3, 1, 6 are all its factors, right? So for a given polynomial also, it will have different factors. We would have multiplied something to get such huge polynomial, right? So how do we do that? For factorization method, always remember, first you multiply the cth term, the constant term, with the highest degree, which is x square, right? So you get 6x square, and then you will make two values for it. Now you will make use of all the factors of 6. Okay. Now 6 has 2 3s are, 3 1s are. So if you see, what are the factors of 6? 2, 3, 1 and 6. Now what you have to do is, first write this negative, whatever sign you will have here, first write it off here. Now since I don't have a sign, that means it is plus. So minus into plus becomes minus here. So both the terms that you will be making use of are negatives. Now these two terms are nothing but the factors that are coming out of 6. Now you have to use any two factors, both are supposed to be negative, to get 6. Now, and to finally, using those two symbols here, you are supposed to get back minus 5. Now how is that possible? Let us check with 6 and 2. Minus 2 minus 6. Is it minus 5? No. So we will not pick that. Next, let's try 2 and 1. Minus 2 minus 1. It's equal to minus 3. So it is not minus 5 again. So we will not pick that. Let's try this and this. So minus 2 and minus 3 is minus 5. So we have our solution, which is minus 5 here. So minus 2x and minus 3x. Now if you check, minus 2x into minus 3x is 6x square. Minus 2x into minus 3x is minus 5x. So we are on the right track. Now how do we proceed with that? So always remember, first you have to factorize whatever is given to you, and then what do? You basically try the factors of it. For signs, you will be making use of the middle term, right? Now after this, you will write minus 5 as minus 2x as minus 3x plus 6 equals 0. Now once that is done, you will now classify them as two numbers, right? Grouping two numbers each. So we will have two groups. Now take whatever can be taken common. X into, what is left now? X minus 2 will be left, because when we are taking something common, we are dividing it by the same variable or number for that matter. Now here I can take 3 common, but if I take plus 3 common, can I get x minus 2 again? I will not be able to do that. Hence what I do is, I will take minus 3 common. So when I take minus 3 common, x is remaining. Now this becomes minus 2 here equals 0. Now whenever you take something, one sign common from it, always make sure. So I was telling you, whenever you take, so when you have this part, right? So I have addition to it. In mathematics, like I told you in the previous module, whenever you do any sort of operation, you are supposed to come back to the previous step. Now let's check if this is right. X into x will give me x square. X into minus 2 is minus 2x. Minus 3 into x is minus 3x. Minus into minus is plus. 3 into 6 is, 3 into 2 is 6. So we are coming back. Now if I hadn't taken this minus common and it had been plus, it would have generally just been minus and this one as plus, which is not something we want. Therefore, we took minus common there. So this becomes x minus 2 here. Now what you do, since you have grouped, now again this entire thing, there are two things here. So you will again group. Now you take x minus 2 common. So whenever you are factorizing, remember the second term is also supposed to be the same thing from here. What is left from here? I have x left. What is left? Minus 3. This is equal to 0. Now what you do? Now you will say x minus 2 equals 0 and x minus 3 is also equal to 0, because each of these terms, this and this term, can be equated to 0 in quadratic equations. Now from here I can know this is x is equal to 2 here and x is equal to 3 here. So we found out x value is 2 and 3. Now remember I told you since they are quadratic equations, x degree is 2, so we will have 2 roots. So here solutions are called roots, therefore we will have 2 roots. Did we get 2 roots? Yes, of course we did get 2 roots here. So 2 and 3. Now this was for factoring, we got 2 and 3 for this particular one. Now for the same equation, let us try completing the square. And I will also tell you why we generally don't happen to use completing the square and how factorization for this particular problem is much easier than the other two types of solutions. Now coming back to this completing the squares, let's take a different thing for you to understand. Now completing the square. For completing the square, what we generally do is, we have x square minus 5x plus 6 equals to 0. For completing the square, you need to have a prior understanding of 3 formula, which is a square plus b square plus 2ab. Then you have a square plus b square minus 2ab. Then you have a square minus b square equals a minus b into a plus b. So these are some general formula that you study in starting from 8th grade. So these 3 formulas are something that you need to have a prior understanding to understand completing the square method if you don't focus a lot more than the others would do. So now coming back to this problem and how we could solve it using completing the square. Now I told you it is supposed to look like this, but here I have minus, right? So whenever I have this x, that means it is of this format. So therefore we will be making use of only this formula, a square plus b square minus 2ab. Now I have a square here minus 2, a and b. I already know a is x, but do I have a b? But I don't. But here I have 5. So what will I do? I will simply divide by 2, right? So if I simply divide it by 2, what will happen now? What did I do? I multiplied and divided by 2. Now this is my a square minus 2a and b, right? And I already have a 6 here. But does that finish my problem? It does not, because I need a b square. To do b square, you need to again add and subtract b square. Now what is our b? Our b is simply 5 by 2. So what will you do? So for this particular matter, I will just erase this. So here I will continue it down here. Let me rewrite this. So this is x square minus 2 into x into 5 by 2 plus 6. So this is of the form of a square. I will also be erasing this part because we are only making use of the negative part of it. So this is in the form of a square minus 2 into a into b, right? I also need a b square for that matter. So b square is just this. So what will you do? You will add 5 by 2 whole square and you will subtract 5 by 2 whole square. Now I told you again, I am repeating myself, I am always telling you whenever you are solving mathematics, when you proceed to the next step, right, you will always check if from the current step you can go back to the previous step or not. If you are not able to go back to that, that means your problem is wrong. If you are able to go back to your previous step, then of course you are on the right path. So now coming back to this, let us check if we are on a right path or not. Now if I cancel these two here, I will be left out with 5x. So this is plus and minus of this goes off. So I have x square minus 5x plus this, which is my initial question, right? So I was able to go back to my previous step, hence I am on the right track. Now what will we do? We will group all of that. Now this and this is what I need. So x square minus 2x into 5 by 2 plus 5 by 2 whole square plus 6 minus 5 by 2 whole square. So this is something we will keep it aside. Again, we have 0 here, so equate these to 0. Now, this looks as a square plus b square minus 2ab. What is this equal to? A minus b whole square. So what is a from here? I clearly know it is x. What is b? It is simply 5 by 2 whole square. So we have come to one conclusion. Now after this, what do? We will have to solve this one. For this, let us put a bracket. Since it is position, it doesn't matter if the bracket changes or not. 6 minus, I have 25 by I have 4, which is equal to 0. So from here, I have x minus 5 by 2 whole square plus, this is 6 4s are 24, 24 minus 25 is 1, which is simply minus 1, right? So for that, again, LCM, HCF is very important for you to understand this. So minus, I have 1 by 4 equals 0. Now all you have to do is just simplify this. How will you simplify this? Let me write this one here, right? So for this one, it simply is x minus 5 by 2 whole square equals 1 by 4. I am sending this to the other side, so it becomes positive. Now to remove this square, what do? We simply take a square root, or when I send this to the other side, it becomes square of that particular number. If you want to check, you just raise the powers by 2. So this becomes x minus 5 by 2 equals 1 by 2, because I am taking a square root on this, because it is a square on the left side. If it was a square root on the left side, I would have squared on the right hand side. But since it is not, since it is simply a square, we will be taking a square root. Therefore, it becomes 1 by 2. Now send this to the other side. I am going to get, now one more thing that you need to know is, when I am taking a square root, it gives me plus and minus solutions. Why is it giving me a plus or minus solution? Because from here, if I just take one solution, I am going to get only one solution. But I know quadratic equations deals with two solutions. Therefore, I am going to write plus or minus x. Now from this, what we get is, let me take another part. So we had x minus 5 by 2 whole square minus 1 by 4 equals 0. We sent it to the other side, x minus 5 by 2 whole square equals 1 by 4. We took a square root, x minus 5 by 2 equals plus or minus 1 by 2. Now what you will do is, you will take one solution for plus 1 by 2, you will take another solution for minus 1 by 2. So you will get two solutions from here. X minus 5 by 2 equals 1 by 2. Another one is x minus 5 by 2 equals minus 1 by 2. Now all you have to do is send this to the other side. So x from here will be equal to 1 by 2 plus 5 by 2. So if you see, we have like fractions. So this is 6 by 2, which is 3. So x value is 3 as of now. One value is 3. The other value is, so this goes to the other side, minus 1 by 2 plus 5 by 2. So this is 5 minus 1, which is 4. 4 by 2 is simply 2. So we got x value as 3 and 2. Let's check if it is correct or not. So here you see 2 and 3. We also got 2 and 3 from this. So from here, I will just erase this part. Therefore, I can just simply write my solution for that. So what did I get? My solutions were 2 and 3 again. So from factorization also I got 2 and 3. From completing the square also I got 2 and 3. Now let's check if from quadratic also we are getting, the formula also we are getting the same solution or not. So to do the formula, I told you x is equal to minus b plus or minus under root of b square minus 4ac whole divided by 2a. Now this comes from this generalized equation of ax square plus bx plus c equals 0. So a, b and c is from where you are getting all these notes from, right? So for this equation, we have x square minus 5x plus 6 equals 0. So for us, a is 1, b is minus 5 and c is simply 6. So we will be applying all of this value in that particular equation. So what am I getting here? X is equal to minus b, minus of minus 5 plus or minus under root of minus 5 whole square. So minus into minus is plus. So I am going to get 25 minus 4 times a is 1, c is what? 6 whole divided by 2 into a is again 1. So from here x is equal to 5 plus or minus under root of 25 minus 4 6 are 24. So 25 minus 24 is 1 divided by 2. So x is simply 5 plus or minus 1 by 2. So you are going to get two values here. One is x is equal to 5 plus 1 by 2. Another one is x is equal to 5 minus 1 by 2. So what did you get? X is equal to 5 plus 1 is 6, 6 by 2 is 3. Again, x is equal to 5 minus 1 is 4, 4 by 2 is 2. So what am I getting? My other solution is also 2 and 3 from this particular equation. So if you see, my entire idea was to find the factorization of this entire equation. So for that, what did we do? We found out using factoring, we did completing the square, we did quadratic equations also. But we know we were able to come back, or we were able to do this entire thing using this faster, this factoring faster. Why? Because we already knew the factors of 6 very easily. But then for the completing the square, what did we have to do? We had to do so much things, right? So therefore, this is not this is extremely time consuming. Therefore, it is very less efficiently used, right? It took me literally 4 or 5 minutes to come to that particular solution. Of course, I could have skipped a few steps, but then it would take you a lot of time to finish all of that. But here again, quadratic formula, if I had these constants to be more than, let's say, 10, 20, for which it would be difficult for me to find out the factors, that would have made sense. But it does not make sense for me to, sit and apply all the formula for these simple values like 5, 6 and 1, right? It makes no sense. Therefore, it is efficiently used for factoring here. For quadratic equations, you will use, so the quadratic formula, when the values are bigger in number, that is when you will use the quadratic formula. Now here again, this can also be solved using all of three. All of three will give you the same solutions, provided whatever is efficiently used. Mainly I am again telling you factoring and quadratic formula. These two are the most important topics of this quadratic equations. Now coming back to understanding this quadratic formula here. So you get one more type of questions from here. So the formula is x is equal to minus b plus or minus root of b square minus 4ac by 2a. Right. Now we know the value for positive roots. So if b square minus 4ac, right, if this is equal to 0, right, if it is equal to 0, what will I get? I will get a single solution for this, right, single and repetitive solutions. So remember, when this is equal to 0, this is called as the discriminant. Let me erase this for you so it becomes easier for you to note it down. So discriminant, when this discriminant is equal to 0, that's when you will say that the roots are real and repetitive. How is this possible? Let's say I have an example which is x square plus 2x plus 1 equals 0. Right? When such is the case, you have real and repetitive root. So here our a is equal to 1, b equal to 2, c equal to 1. So from here, what will I get? X will be equal to minus 2 plus or minus root of 4 minus 4, a is 1, c is also 1, divided by 2 into a is 1. So x is equal to what? Minus 2. This entire thing becomes 0, so it makes no sense for me to write it. So divided by 2 simply is minus 1. We will write it twice. Why am I writing twice? Because I know it is quadratic equations that we are dealing with, right? So therefore, since you have two things, what is this? This is simply x plus 1 whole square as a formula for this, right? So what am I getting? I am getting twice of it. So therefore, I have repetitive. But are they real? How am I telling if it's real or not? Since I don't have an imaginary number, therefore it becomes real. Minus 1 is not an imaginary number. Therefore, I can clearly say that this is a real and repetitive root. That is your discriminant for the first part. So what did we study? We saw first one where root of b square minus 4ac is equal to 0. For this, what did we get? Real and repetitive. Now we have two more types. The second one is when root ac, let's say it's less than 0. What happens to then? If this is less than 0, of course you think this would be real, right? But is it repetitive? It is not. We just saw for this particular equation. Was it repetitive? It was not. We got 2 and 3 as a distinct number. So this is real and distinct. Distinct meaning they are different from one another. The third type is when this discriminant, let me write this. So this is known as our discriminant. So our discriminant is greater than 0. When this becomes greater than 0, what happens? We get imaginary root. Imaginary, and you can get distinct, or so simply writing imaginary would be a better option. Now, we all enjoy graphs as such. Let us understand how linear equations and quadratic equations for that matter vary in graphs. Quadratic equations are generally a parabola. Parabolas have four types of parabolas. One is which opens to the x-axis, another one is which opens to the negative x-axis, one is that opens to the positive y-axis, and another one is something which opens to the negative y-axis. Apart from this, parabolas can be placed anywhere like this, or we can have it like this also, anywhere, but then provided it should have a decent equation for it. Now, parabolas are not something that is asked when it comes to aptitude, but linear equations for understanding how statistically something is changing with respect to something, because I told you in linear equations we are generally understanding how one quantity is depending on the other quantity. So we always have this comparison in mind when we are talking about linear equations. Therefore, this linear equation graph is very important. Linear, I told you, is a straight line. So always remember, a linear equation will have a straight line. Now let's check if that is true for that or not. So we have y is equal to x plus 1. So this is how the equation of y is equal to x plus 1 looks like. So what is this? This starts, it is never ending. It keeps on going with more values of x, right? So with this value, this entire value keeps changing, right? So this is our positive x axis, this is our y axis, this is negative x, and this is negative y. So with every value which is given to this particular x, our y value keeps changing. So if we see again, it doesn't matter how it's changing. Only thing that you need to remember is with different values, I am also getting a straight line. So here we have a straight line again that you can see for a linear equation. Now here y is equal to x plus 1 is what kind of linear equation? It is of course a linear equation because the variables have 1 as their degrees, highest degrees, but they are linear equations in two variables. So we have linear equation in two variables. Only when we have two variables, we will be able to tell that there is some sort of comparison that is being made. So now let's start with our practice problems. So generally these are the minute questions that are asked. It's not, huge thing for us to understand all of that. Now here it's best for us to either use the factorization method or the formula that was used, the quadratic formula method. Let us try using the quadratic formula to find out the solution for these two. Now the question is x square minus 7x plus 10 equals 0. So if you see, a value is simply 1, b value is minus 7, c value is 10. Now from here we have x equals minus b plus or minus root of b square minus 4ac whole divided by 2a. Now from here what do I get? X is equal to minus of, I have b as minus 7 here. So negative of negative is a positive number which is 7 plus or minus under root of b square. B square should ideally be 49 because we are again multiplying negative with a negative, so it becomes 49 minus 4 into what is a? A is our 1, c is 10 whole divided by 2 into 1. Now, I'll tell you why I chose to use this particular method instead of choosing to just simply factorizing it. Of course, factorizing would also give me the same solution. But then one more thing is when we are doing this, right? So 10 into x square. So the factors would be ideally 1, 10, 5 and 2. Again, we know we will have to pick two negatives. So 5 and 2 would ideally be our solutions. That is, you do a lot of mental math and then you understand that okay, 5 and 2 are my solutions. But I chose to do this because I don't really need to have the knowledge of understanding factors. All I have to know is there is a formula, I need to know what we have to put in what kind of places, and then I just have to substitute to find the formula. So to do this again, now x is equal to what? 7 plus or minus root of 49, this is 4 times are 40. So 49 minus 10 is 49 minus 40 would be simply 9 divided by 2. So root of 9 is 3. So I am ideally going to get x equals 7 plus or minus 3 whole divided by 2. Now I also told you plus or minus are two different values. So first value would be x is equal to 7 plus 3 by 2. Second would be x is equal to 7 minus 3 by 2. So 7 plus 3 is again 10, 10 by 2 is 5. So this is going to give me 5 as my solution. This is going to give me 7 minus 3 is 4, 4 by 2 is 2. So I told you by mental calculation also you were able to reach to a position where you said 5 and 2 are my solutions, but here with a formula we were able to come up with a solution that 5 and 2 are my solutions. Now coming to why I didn't choose factorizing as my main problem solution for this is I know the factors are 5 and 2. But sometimes what happens is, now this was easy because minus is my only, there is just one negative, but what if this was also negative? That would have made it very difficult for me to understand which one is negative, which if it's minus 5 or just 5, if it's minus 2 or just 2. Of course, minus 2 and 2 are both distinct numbers. Just 2 and minus 2 have variations in the symbols or the signs that they are used. So therefore, it is always best when such cases arise, it's easy for you to go with the quadratic formula instead of factorization. So factorizations for smaller solutions. If we, let's say we have it till 9 here, only until then you will be using the factorizing method. So here ideally our solutions are 2 and 5 for that matter. Let's come back to the second solution. Now they are asking us find the roots of 2x square. I'll rewrite this equation. 2x square minus 4x minus 6 equals 0. And I have different values for this. So whenever you see none of these, don't be scared if it's actually none of this or it's always none of this. That is not the case. Sometimes it is none of this, but be confident with your answers because you will be scared if why are these given to you, right? So you will be scared of all that, but make sure you practice a lot and that's how you can gain confidence in your solutions. So for that, first thing is, so in our question, so ax square plus bx plus c equal to 0. So this is my generalized version of a quadratic equation. Now here if you see this 2, 4, 6, these are all multiples of 2. So what will I do? I will simply take 2 common. So if I take 2 common, this will be x square minus 2x minus 3 equals 0. So when such is the case, 0 divided by 2 is simply 0. So I am left out with x square minus 2x minus 3 equals 0 as my particular equation. Now let us try and find using our, again, quadratic method is also okay, quadratic formula method is also okay. I will be using the factorizing method. For this, what do I have to do? First multiply these two. So minus 3x square. I have two solutions. From here, write negative. Now negative into negative is simply positive. What are the factors of 3? It's 3, 1 and 2. So these are the three factors of 3. Now check what can be used. I know I can use 3x and 1x. So two factors are used. 3 minus 3 into minus plus 1 is minus 3x square. Minus 3x plus 1x is minus 2x. So I was able to do that. So therefore I can say x square minus 3x plus x minus 3 equals 0. Now group them as 2. Then you will take x common. X minus 3 is left when I don't have. So if you see x minus 3 is something that I need. So when you don't have anything in common, just write plus 1. So this gives me my x minus 3 equals 0. Now from these two I can take x minus 3 as common. So x minus 3 into x plus 1 equals 0. Now from here what do I get? I will write this here. I will get x minus 3 equals 0. From here x is 3. And I will also get x plus 1 equals 0. So x value is minus 1. So let's check if I have that in my solutions or not. It says minus 1 and 3. I have 1 and minus 3. So this is not the solution, this is not the solution, this is not the solution. Therefore, none of this is my solution. So not always none of this is not my solution is what I am trying to say. If you see none of this as my solution, of course you will get scared. But make sure your method is right to get the proper solution for it. So therefore from here I can clearly say none of these is my solution. I hope you were able to understand quadratic equations as well as linear equations. So in linear equations, all we did was we knew there is a generalized format for linear equation, which is ax plus b equals 0, and a, b, c are all different constants. We then came across quadratic equations. In quadratic equations, the final values are called roots. Roots can be different. We had a discussion on discriminants as well. Now let us understand what progressions are. Now progressions, we have two types. One is arithmetic progression and geometric progression that we would be making use of here at this particular point. Let us start with understanding what is arithmetic progression. Now here the definition says a sequence where the difference between consecutive terms is constant. What do you mean by this term, which is consecutive term? Consecutive term is one after the other. Let's say 1, 2, 3, 4, 5, 6. This is, let's say, a sequence. This can be a random sequence. Sequence is flow of numbers. Now 2 is the consecutive term of 1, 3 is the consecutive term of 2, and so on, right? There is something called as predecessor also. Predecessor means one before that. So 1 was the term before 2, 3 was the before term of 4, right? So these are called as predecessors, and the next ones are called consecutive. So when such is the case, there is a sequence, there are consecutive terms, and the difference between them is supposed to be constant. For the same equation, sequence, 4, 5, 6 and so on, if you see this is minus 1, this is minus 1, this is minus 1. Or I can simply say plus 1 also. If I go this way, it's minus 1. If I go this way, it's plus 1, right? So each of them is simply, there is a difference of 1. That's what they're saying. So the difference is supposed to be constant. That's when you get arithmetic progressions. Now this A and D that you're seeing here, A and D, and then you have 2D and so on. A is our first term. What is D? D is our constant difference, or simply called as difference. Constant difference, because difference is supposed to be constant in arithmetic progression, so there is no point of saying constant difference, it's simply difference. So how does it look like? Now if I consider this equation, right, this sequence, I am so used to saying equation from your previous solutions that I am again saying equations. Instead we'll use sequence from now on. So it goes on. So I don't know where it's ending, the sequence, it goes on. This means infinite, okay? So it keeps continuing, 3 dots. So first term means this term. So A is 1. D means constant difference. D is simply 1. How do we find D? You go to the second term minus the first term. Third term minus the second term. Fourth term minus the third term. That's how you find out the difference. I know the difference is simply 1. So let's check if this is true or not. So A is simply 1. A plus D. So 1 plus 1 is 2. A plus 2D. A plus 2D. Again, it's 3, right? Then you get 3D, 4D, 5D, 6D, 7D and so on. That's how the sequence keeps on going. Now, what is the nth term? Nth term means a term which is in the nth position. I do not know what the position is. So this is my nth term. For nth term, we just write Tn. This is equal to a plus n minus 1 times d. Okay. Now if you see 1, 2, 3, 4, 5. Let's pick this 4. How did we write this? This was a. This was a plus d. This was a plus 2d. This was a plus 3d. Then it would go on as a plus 4d. So now if you check, if my fourth term is this, that means we are only considering 3. So therefore if we are finding the nth term, we are supposed to write n minus 1th term as our general equation. So general term, which is the nth term, is considered as Tn equals a plus n minus 1d. So this is a very important thing that you need to know. Then there is sum of n terms. Sum of n terms meaning we have so many terms. I don't know how many terms we are talking about. We just have a notion of n terms. So for those, what is the sum? So for that we write it as Sn, S meaning sum, N meaning nth. So this we write n by 2 times 2a plus n minus 1 times d. So this is what our sum of n terms look like. So you need to know these formulas. So this and the nth term for that matter. Example is here 2, 4, 6, 8. Next term would be 10, 12, 14, 16, so on. Right? What is the difference? 4 minus 2 is 2, 3 minus 4, 6 minus 4 is 2, 8 minus 6 is 2. So there is a constant difference. So therefore it becomes a sequence, right? Next we have 5, 10, 15, 20. So here the difference is 5. So the difference here is constant between each term. So that's how arithmetic progressions look like. Let's go ahead with the practice problem. It says find the 10th term of the sequence 3, 6, 9. Let us find out how this looks like. 3, 6, 9. Then if you see, what is my first term? First term is 3. What do you think our D should be? D is 6 minus 3 is 3. 9 minus 6 is again 3. So simply D is 3. What do you think the next term will look like? It's 12 and it goes on. Right? We are asked to find the 10th term. So that means T10. What is the formula? It should ideally be A plus N minus 1, which is 9 into D. Right? So what is our A? A is 3 plus 9 times D is 3. So this is 3 plus 9 3s are 27, which is 30. So this is our solution. If you see, this is simply 3's table. The 10th term, that means 3 10s are 30. So that is also possible. But if you are just using the AP's term, because there are so many ways of solving one simple problem, right? But then you need to apply that analytical mind of yours to understand how it's working, right? Here I could have simply written it as 30. Instead, what did I do? I chose to solve this only because I am teaching you. Otherwise, I would have simply put it as 30. So that is supposed to be coming to you as well. How will that come to you? Only with practice. And how will you practice? Bring in a lot of problems, solve a lot of past paper problems, and that's how you will be able to solve it as well. So there were two ways of solving this. One is using the AP method. Another one was, I know the 10th term means 3 10s are 30. So what did I do? First I had to identify what this is, right? So I knew this was 3's table. So 10th term is of course 30. So that's how you will do it using your common sense as well. We have the second problem now. Calculate the sum of first 20 terms of this. Now, so for this you need to know the formula, which is Sn equals n by 2 times. Now here the only difference is you write 2a plus n minus 1 times d. So what is our n? N means the term that is being asked. So first 20 terms. So n means 20. And I know A is simply 5 because that is our first term. And then D is simply 5, 10, 15 means it is simply 5. Correct? So the difference is 5. Now we will apply this. So S20 equals. Now again one more thing, we applied that logic of 3 10s are 30 there because we were finding which term we are talking about. But here we are finding the sum of all of it. So if you see 5 plus 10 is 15, 15 plus 15 is 30. That's how the sum is calculated. It's not the term we are talking about, it is the sum we are talking about. Therefore, it is not possible for you to guesswork here. All you have to do is first find out using the formula only. So n will be 20, so 20 by 2. Now 2 times a is what? 5 plus n is again 20 minus 1, d is again 5. Right? So now 20 by, let's write this directly. So 20 by 2 is 10. Now this is 10 here plus 19 into 5. So I have 10, then 10 plus, what do we do next? We have to multiply this. So 19 5s are simply 95, right? Yes, so 9 5 is 45, 4 and 95, that's how we get. And so 95 plus 10. So we have to first solve whatever is in our brackets. So 95 plus 10 is 105. 105 plus 10 is 1050. So this is our sum. So solution is simply option B. So that's how you will solve for these. So I hope you were able to understand what arithmetic progressions are. Now we will be understanding what geometric progressions are. So geometric progressions are again progressions, meaning it is going to be a sequence, but here each term is multiplied by a constant ratio. Now ratio meaning you will have to divide by one another. So how does it look like? AR square, then it is AR cube and so on, right? What is the general term? So Tn should ideally be A r power n minus 1, because if this is the fourth term, so I have 3 here, right? So if it's the nth term, it is supposed to be n minus 1. Now there are two types of GPs. One is a finite GP, another one is an infinite GP. For finite GP, the Sn, the sum is generally A times, I will write this again, just make sure you make a note of it properly. A times, so this is Sn equals A times 1 minus r power n whole divided by 1 minus r when r is less than 1. So if r is less than 1. Now how does that look like? The GP will look like 1 by 2, 1 by 4, 1 by 8, 1 by 16 and so on. So if you see, if you divide 1 by 4 by 1 by 2, the ratio is 1 by 2. So 1 by 2 is less than 1. Therefore, we will be using to find this sum. Now Sn will be equal to A times r power n minus 1 divided by r minus 1 when r is greater than 1. Now what does this look like? If you see 2, 4, then I have 8, then 16 and so on. The ratio is simply 2. 2 is greater than 1, therefore we will be using the second term, which is A times r power n minus 1. Let's use a different ink for our better understanding. Now so much is understood. This is when we have two different types. Now let's say I have an infinite GP, which is Sn is equal to infinite GP, meaning there is a lot going on, I do not know where it is ending. So that's when we use Sn equals A by 1 minus r to find out what is the sum of the entire GP. So this is how it looks like. I just gave you the example here and of course here as well. So the ratio here is 2, the ratio is again 2 here. What is the difference between arithmetic progression and geometric progression? There we are considering common difference. Here we have constant ratio. So make sure you do not get confused with GP as well as AP. It is as simple as AP. Only thing is everything goes in multiplication. There it is either addition or subtraction for that matter. Okay, so let's come back to our practice problems. We are asked find the fifth term of this. Let's check if this is actually in GP or not. So first is you divide 6 by 2, which is 3. Then you divide 18 by 6, which is 3. So of course this is in GP. So what is our first term? First term is 2. What is our difference? Sorry, we don't write D, we write R. R is equal to 3. What is asked? Fifth term. So I told you we write Tn here as A power R power n minus 1. A into R power n minus 1. So we are asked T5, that means we have to find A R power 4. So what is A? A is 2. R is what? 3. 3 power 4. So you have to write 2 into 3 power 4. 3, we have 9 into 9. So it will be simply 81, which is 162. So 162 is our final solution. That's it. Coming to the next problem, we have calculate the sum of first 4 terms. So only these terms of the GP we are supposed to find out. So what does Sn look like? Sn is simply A times, let's see if this is greater than 1 or less than 1 first. So 3 by 1 is 1, right? 9 by 3 is 3. sorry, this is 3. So everything, the ratio R is simply equal to 3, A is equal to 3 again, sorry 1, right? A is equal to 1. Yeah. So A into, so since this is greater than 1, we will be using R power n minus 1 divided by R minus 1. So the second formula for this. So Sn, we are finding the 4 terms. So therefore A is what? A is 1, R is 3, 3 power 4 minus 1 divided by 3 minus 1. So S4 is 3 power 4 is 81, 81 minus 1 is 80, 80 by 2, which is simply 40. Is that there in the option? Yes. So option B is our solution, which is 40. So all you have to do is have a bit of analytical mind here. Here you have two problems because R can be, more than 1 or less than 1. Check first whenever you see a GP, check what is the ratio and then only apply the sum formula. With that, we have almost ended the learning part of our entire module. Let us practice some problems which were asked in our previous questions to have a better idea of the entire concept, starting with this. So this is very simple. They said you have to find out the value of x. 3x plus 2 equals 17. So from here x is simply 17 minus 2 and from here x is 17 minus 2 by 3. 17 minus 2 is 15, 15 by 3 is simply 5. So our solution is option A, which is 5. Next we have to solve the second one, again quadratic equation. So x square minus 8x plus 15 equals 0. What will I use? I will basically be using the quadratic formula. So from here I know A is 1, B is minus 8, C is what? 15. So from here x is equal to minus b, minus and minus gives me plus. I will not be substituting all of that because by now you should be able to do all of this quickly, right? So this is 8 plus or minus root of 64 minus 4 times A is 1 into 15 whole divided by 2. So x is equal to 8 plus or minus root of 4 into 15 is 60, 64 minus 60 is 4. So that is simply equal to 2 here divided by 2. So x values would be x is equal to 8 plus 2 by 2, which is 10 by 2 and 5. Another value would be x is equal to 8 minus 2 by 2, which is 6 by 2, which is again equal to 3. So the two values are 5 and 3. So 3 and 5, option B is my final solution. Next we have find the sum of 10 terms in this particular. See, can you tell me what this could be? This is simply, you see, 4 minus 2 is 2, 6 minus 2 is 4. So this is in the form of an AP, right? So we have to find the sum of the first 10 terms, which means you're starting from 2 ending at 20. So 1 to 20 you have to find the entire solution. So for this Sn is nothing but n by 2 times 2a minus n minus 1 times d. So Sn we are finding 10. So 10 by 2. What is our first term? First term is 2 here, 2 into 2 minus n minus 1, so 9 into our d is again 2. So this is simply 5 times 2 into 2 is 4, 4 minus, sorry, we have plus here, right? We can't have negative because then it goes as negative. Negative sum is not possible at this particular point because we don't have any negatives. So plus 9 into 2 is 18. So 18 plus 4 is 22, 22 into 5. So you get 10, 1 carry, 5 2s are 10, 11. So 110 is my final solution. 110 is not possible here, right? So the solution, either we could say this was none of this. So the solution is none of these because the solution is clearly 110. Next question is find the sixth term of 1, 2, 4 and so on. Now here this could either be a AP or a GP, right? But let's check what that is. So first whatever you do, 2 minus 1 is 1, 4 minus 2 is 2. So this is of course not a AP, hence we clearly know this is a GP, right? So now what will I do? I know our first term is 1, our ratio is 2. What is our sixth term? That means T6, and T6 is AR power 5 because it is n minus 1. So from here I know A is 1, R is 2, 2 power 5. 2 power 5 can be written as 2 square into 2 cube. From here 2 cube is 8, 2 square is 4, 8 fours are 32. So my final solution is 32. Okay, so we finally have another problem based on our arithmetic equations, our linear equations. So we have 2x minus 3 equals 11. Take a minute before I solve it. Pause your video and then do it. So from here I know it is 2x equals, this goes to the other side, becomes 14, x is simply equal to 7. So my solution is option C. Next we have 3x square plus 7x minus 6 equals 0. Let us again find out using the quadratic formula. I know A is equal to 3, B is 7, C is minus 6. Now to do this, I know x is equal to minus b. So minus 7 plus or minus root of 49 minus 4 into, I have 4a is 3 and I have c is minus 6 whole divided by, I have 2a, so 2 into 3 is 6. So I have written this without using the formula as such, but it is the formula, direct substitution. So from here minus 7 plus or minus root of. Now minus into minus is plus 18, so 12 into 6 which is 72, right? 72 plus I have 49, so 11 1 carry, I have 12, so 121 by 6. Now to find this one out, I told you need to remember the squares and roots of numbers from 1 to 30. So 11 square is 121, so square root of 121 is directly simply 11. So from here I can say x is equal to minus 7 plus or minus 11 by 6. So we will have two solutions again. X would be equal to minus 7 plus 11 by 6, or x is equal to minus 7 minus 11 by 6. So I will get a negative and a positive solution. That is only possible in these two or none of these, right? So C cannot be my answer at all. So from here 11 minus 7 is 5. So I have 5 by 6 as my one solution. Another one is 11 minus, so minus and minus will have to be positive. So 11 plus 7 is simply 18. 18 by 6 is simply 3. So 5 by 6 and 3. So do we have that solution? We don't. That clearly means it is none of these. So from here we can conclude saying none of this can also be my solution from here, because we clearly know it's 5 by 6, because 11 minus 7 is simply 4. Anyways, it will not give me a solution because it's not going to give me a whole number. So 4 by 6 and 3 is simply none of this for that matter. With this, we have come to an end of our module. So here, let's quickly have a recap of what we studied. We studied about linear equations, where we saw linear equations were basically straight lines giving us different relationship with different variables. Then we also saw quadratic equations for parabolic curves with roots. So under that we saw discriminants, and then we also had three different ways of understanding the nature of roots, if they were real, distinct, real as well as repetitive, real or imaginary. And then we also understood about progressions, patterns in any given sequence. So we had arithmetic progressions, we had geometric progressions. We also understood how to find the sum of all of them, mainly focusing on the term which we are supposed to use, right? So with that, we will be concluding this particular module. Make sure you are practicing on a regular. So the tip is mainly to practice consistently for faster problem solving. Other than that, there is no other easy step for this. And there is also a pun intended joke. Every problem has a solution. Keep solving to get the solution for that. With that, we will conclude this module. Make sure you make the best use of it, and all the very best.